In case I haven't mentioned it before, you took advanced functions, and advanced functions is advanced graphing, because functions is a fancy word for saying that you're going to graph or sketch. So we've done some of that already this year with polynomial functions and rational functions, and it's time for trig. So we're going to focus on the sine and cosine curves. That means I'm going to take a few minutes to go over what the sine and cosine curves look like in their original form before we do any of these things to it. So I am going to put this on full screen so you don't have to see the pie graphic. And then we'll talk about what each of these things do. This should be a review from grade 11. If it isn't, you will have to put some pieces together with today's note and with my help. So again, just like anything, I shouldn't have to say it at this point, but I will again. If you need a hand, let me know, please. So back to full screen or widescreen. And just like with the graphs that you learned about in grade 11, which were the parabola, and I'm going to draw these without axes. So just like the parabola, or the squiggle, or the V, or the J shape, or the hyperbola. There was a line. 1, 2, 3, 4, 5, 6. I'm missing something. Oh, the one-armed parabola going sideways. So I'm not sure if I covered all of them. It's been a while for grade 11 for me, but I know that those were all covered. Just like those have transformations, meaning that they are stretched and compressed and moved around, so translated. We're going to have to take trig, sine and cosine curves, at least for this course. We're going to do the same thing, but I want to show you where these letters belong, so that you can more easily recognize them. So if you've got the sine curve, your amplitude, which is how stretched or compressed vertically your picture is, it sits right after the equal sign. I'm going to use sine first. Then we have to talk about a potential change in wavelength, or a period change, which is a horizontal stretch and compression. Then we talk about a phase shift, so a sideways movement, a horizontal translation. Then finally, we can move a picture, a graph, the sine curve, up or down. So we have that. Having said that, maybe this information is in a larger bracket, maybe it isn't. Then, when we're talking about cos, it is very similar, but I'm going to throw in one tiny little change. Actually, let's make it two tiny little changes. First thing is a reminder that y is the same as f at x. Your amplitude would come, then I would tell you that you're drawing a cosine curve. Again, you could have square brackets and round brackets. I'm not going to put the square brackets in this time. Instead of an x, you could have a theta axis, and I'll show you in a minute what difference that makes. You would still possibly have a phase shift, and you would still possibly have a vertical displacement. So each of these letters indicates a change in the original curves, which are y equals sine x or theta, and y equals cos x or theta. So I've swapped them here. Not that it matters all that much. So let's go over some things about how to graph them. I have left, not here. Where is it? Oh, on the final page. I've left some links, and I will show you them in a minute, or over the course of this note. The first thing I want to do is make you realize that these graphs are subtly different. First thing is, when you're drawing these, it is my suggestion to you that you draw them very wide and not so tall. I'm going to eyeball this here. I'm going to draw for you, first of all, a sine curve to remind you, hopefully, what it looks like. And I'm going to do it in red, so I'm just going to say that this is y equals sine x. Now, hopefully you realize there's a 1 here. That means we have an amplitude of 1. What that means is the sine curve, which is just a bunch of speed bumps, goes up to the 1 and down to the -1. So I need a scale on my y-axis to indicate how far up or down it goes. The next thing I need is a scale on the x-axis. And you can do it in the other order, but for my personal suggestion, and you may not have done this in grade 11, is that you write down radians across your x-axis instead of degrees. That would be one difference between grade 11 math and grade 12 math. The second thing is, in all of my trig graphing life, I have used 1, 2, 3, 4, 5, 6 boxes is 180 degrees or pi. 1, 2, 3, 4, 5, 6 more boxes would be 2 pi. 1, 2, 3, 4, 5, 6 would be 3 pi. This works for almost everything that I've graphed in my entire life and will definitely work for what I give you in this class. 1, 2, 3, 4, 5, 6, that's going to be -pi. Now, you're kind of lucky you're not sitting near me when I go to do this, but I need you to know that the sine curve, every single sine curve, until movements happen, sine starts at the center. So it starts at the origin. And the original sine and cos curve start and finish their wavelength in 360 degrees or 2 pi radians. And what happens in this space is that you have to have an up bump and a down bump in that order. So I need to split this space in half. And then in the first space, halfway through, the bump will go up to the 1. And halfway through the second space, it will go down to the -1. Now we will have a little more math than just eyeballing this, and this pattern continues forever. So when I say sine starts at the center, I'm actually lying to you, because sine doesn't start and it doesn't end, it goes on forever. But as long as your wavelength is normal, so as long as your period is normal, and we'll get into that today, you will have, if you use my system of 6 boxes for pi, you'll have 1, 2, 3 boxes between each dot. So I can continue this. I can continue this forever in both directions. And what should happen, if I wanted to check your work, and I'm going to give you the visual for this, is all your bottom points should lie on a horizontal line, and all your upper points should lie on a horizontal line. So you shouldn't have any of that kind of thing happening. So I'm going to get rid of these lines because they're cluttering my thought. And the next thing you do is you connect them. Now this is freehand, so you cannot join these with a ruler. If you join them with a ruler, I take off marks, because there's all sorts of little red dots in between here and here, here and here, here and here, here and here. There's all sorts of red dots that we're just too lazy to put on. They're ugly. A couple of pretty ones, but mostly ugly. So if you have trouble doing this, then turn your page sideways and draw a bunch of S's. But I'm going to draw a speed bump here, and my Smartboard bumps would be far better than these ones because I'm using my little tablet thingy. And this goes on forever, which normally I would have you put arrows on the end, but I just hold up. I usually hold up at one of the dots, either the upper, lower, or midline. And you have that picture. The next thing I'm going to remind you about is the cosine curve. Now, it took me years to figure this out, which when you see what I figured out, you're going to think, oh my gosh, I can't believe this lady is teaching me math. But first thing is, and I'm going to change to, well, let's use purple. I'm not going to draw y equals cos x. I'm going to draw y equals cos theta. And the only difference between y equals cos x and y equals cos theta is that instead of putting an x on the x-axis, you put a theta on the theta axis. Otherwise, there's no difference. I'm going to make this be 1 still, so I'm using the same scale as up above. And this is -1. And here's what I recognized many years into my career, is if I lined up the y-axis, I could steal this pi and not have to continually count to 6, which after a while becomes a little bit annoying. It's almost embarrassing how many years, yes, years, it took me to figure that out. So with purple, I need you to remember that cos does not start at the center. Cos starts at its a value, and the a value, I'll remind you, is right after the equal sign. So that means cos starts at the invisible 1. It has the exact same wavelength, so I know that 2 pi down the road, 360 degrees down the road, I'm going to end. And that means I do the exact same system, so I can go 3 boxes and plant my middle dot, 3 boxes and hit my low point, 3 boxes, come back up through the middle dot, 3 boxes, and I can count to 3. I'm not really counting to 3, I'm just kind of judging. So this is the cosine curve. And I think I just wrecked what I wanted to do. But at least I have a good chunk of the cosine curve all connected to each other. What I want you to recognize, yeah, I did, it's separate. What I want you to recognize is the cosine curve and the sine curve are exactly the same, only moved over from one another. So that is something you want to keep in mind. Now I've got this slide here that I skipped over that has some things on it that you might want to take into account. Here is a picture of 0, 0. This is the x-axis, this is the y-axis, and here's sine starting at the center and going off on both directions, starting with its up bump, and again, not really starting, going on forever. And here's cos starting at 1. They've put the scale over here and doing its thing. So they're called to be on different phases. So here's some facts about both sine x and cos x. Y equals sine x and y equals cos x, so no numbers inserted, so you've still got an amplitude of 1 for both of them. You've got a period of 2 pi for both of them because you haven't inserted anything as far as numbers go in there, and because they're completely centered around the x or theta axis, you also have no vertical displacement. So you say that there's a vertical displacement of 0. They differ because they're moved over from each other. So it says here they differ because y equals cos x is pi over 2 units left of what y equals sine x looks like, or that y equals sine x is pi over 2 units right of y equals cos x. And then we'll talk about this stuff a little bit later. So what I want to do is I want to show you that one website, the first one, the first link from the last page, because there is a graphic here. And by the way, if you ever in the future need any help in math, purple math is a good one. Here is a picture, and I'm sorry I can't slow it down, but it starts there. And it does its thing. So here, and it does its thing. And this is the sine curve because it's starting at the center. And if you take a look, the little green and red are making triangles. So I do want you to know that all the values you get from here are actually all the opposite over hypotenuses, hypoteni, from the triangles you make on this circle. So here is the y equals sine x picture in its full, the sine wave, the sine curve. And you'll see that instead of using pi and 2 pi and 3 pi, they've used the decimal equivalents. And then I think if I take you down a little bit further, there's cosine. So same kind of deal, and here's the cosine curve. So just in case you think I'm lying to you, cosine wave. Now before I forget, the title of this is sine and cosine curves, but there's another name for this, and that is if you ever see the word sinusoidal, that just means a sine or cosine curve. So if you're familiar with trig and you know that there's also a tangent curve and a cosecant curve and a secant curve and a cotangent curve, you can ignore all of those because the word sinusoidal means sine and cosine curves only. And I know it starts sine, but it's both sine and cosine. So it doesn't matter which one, it's whichever one applies. So we're going to go on and we're going to do two things with this particular note. One is amplitude change. So we're going to just change how high the bumps go on the y-axis. And the other thing we're going to do is we're going to change the period length. So it may stay that we start and end in 2 pi, so 12 amount of spaces. But it could also mean that we shrink it or we actually make it bigger. So what we're doing today is we're talking about the first two things, a vertical stretch or compression. So we may change it from an amplitude of 1 to an amplitude of something higher than 1 or lower than 1. And we're also going to talk about a horizontal stretch or compression. So we're going to get into that. Now the first things I want to do are two fairly easy-ish ones, and that is simply doing an amplitude change. So that's it for these particular questions. Then we'll move on to amplitude and period at the same time, because those are the first two things you do regularly. So what I'm going to do first of all is I'm going to build myself an x and y axis. And I'm going to put the y on, but I'm not going to put the x on. And the reason I'm not going to put the x on there is because I don't know if it's always going to be x or if I have to toss a theta here. To save myself a little bit of time, 1, 2, 3, 4, 5, 6 pi. 1, 2, 3, 4, 5, 6, 2 pi. 1, 2, 3, 4, 5, 6, 3 pi. 1, 2, 3, 4, 5, 6 backwards, negative pi, and I'm going to glue this all together, and then I'm going to clone it for the one below. And let's see how smart I am. Pretty smart. I didn't put the x on. I need to line these up with the blue marks. There we go. Put a theta here for when we get there. And put an x here because we have y equals sine x. So I am making no wavelength changes. So I know for a fact that this question because it's sine and sine starts at the center, and for now we've got no movements. I can put my first dot here and I can put my last dot here. I also know that I'm going to have a split of 3 still, as in I'm going to go 1, 2, 3, and I'm going to put a dot somewhere. And then I'm going to go 1, 2, 3 again, and I'll put a dot somewhere. And then 1, 2, 3 again, and I'll put a dot somewhere. And I've totally messed that up. And that's because I'm not there yet, and I can move my smartboard stuff around pretty much at will. What I do want you to know is that you need a scale on the y-axis. I left it off. So I'm going to make 1, 2, 3, 4. And the reason I'm doing that is because my amplitude is 4. And then 1, 2, 3, 4 down here as well. And what that does is it takes the dot from what used to be 1 and takes it to 4. So you've stretched your speed bump. This is a speed bump you don't want to go over because it's 4 times taller than what it regularly was. The same thing on your upside down speed bump. You're going to take this to 1, 2, 3, negative 4. So this is a bigger valley. It's a bigger pothole, I guess. And just to put the numbers on, negative 1, negative 2, negative 3, in case you need them. I don't care as long as you maintain a scale on the upper part of your y-axis and your lower part of the y-axis. And now I get to draw the picture. I am going to extend it just a little bit in this direction, and I'm going to extend it in this direction, and then I'm going to attempt to draw my bumps. So this is terrible, but I'm going to keep it because I want you to know that I'm not marking your artistic ability on drawing speed bumps. I am drawing where you place your dots. Did you put in a decent effort to connect them, and did you not use a ruler? So there's the picture. Still a wavelength, a period of 2 pi. So it takes 2 pi amount of space to get back to the beginning. And it's got an amplitude, this time, of 4. So next question isn't that much different, except that it's cos and it's theta. Now I know that because we don't have any up and down movements, because we're not there yet, it's note number 1, I'm going to go up to the 2 and down to the negative 2. If you felt like it, you could be a rebel and put your 2's there. It's totally up to you as long as your scale is consistent. I like it there. So here's the thing. Red. I told you that cos, the cos graph, y equals cos theta, starts at the a value, and I've got an a value of negative 2. So I'm going to start here. So to be perfectly honest, this picture has an amplitude of 2. I know it says negative 2 there, but it's the cosine curve from right here, but flipped. So that means we're going to start down here and do our magic rather than starting at the top and doing the magic. Because I still have, and we're not there yet, because I still have a period of 2 pi, that means at the 2 pi mark, I will finish my curve. Then I can count my 3 boxes and make sure I go through middle, top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, forever and ever, or until you get bored. For me, that's right here. And then do it backwards a little bit. So ooh, that's very bad. So this is an upside down and stretched cosine curve. I do want to flip back to the original cosine curve that we drew. And the reason I want to flip back to this is I do want to tell you that this particular scale on the y-axis is very, very dangerous. So to go 2 boxes is 1, so 1 box is 0.5. Not necessarily the wisest choice depending on your sleepiness and your carefulness. This scale that I used on this cosine curve, or even the sine curve, 1 box is 1. Brilliant and not very dangerous at all. So not a risky move whatsoever. So I'm going to take a break just so I can preview what we're going to do next, maybe set up a couple of grids, and then I will come back to you. So I took a little bit of a longer break and didn't do much fixing, which means another break for my hand in a few minutes. We are moving on to talking about period or wavelength changes for sine and cosine curves. So this is a period change, meaning a horizontal stretch or a horizontal compression. There could also be a reflection or a flip, but that is very doubtful and almost useless because flipping over the y-axis doesn't do a heck of a lot. This means that we are going to take our 12 boxes. If you're using my system, we're going to take our 12 boxes, or whatever you choose to use for pi, and you are going to make it stay at 12 if there's no period change, or reduce to something less than 12, or you may be asked to stretch it to greater than 12. I do want you to know, even though you are taking a graphing/sketching course, sometimes all we do is talk about graphing or sketching. So we don't always have to dig out graph paper or make an axis with a set of rulers every time, or with a ruler every time. So sometimes you just talk about the characteristics and move on. In order to do the period change, it's not simply looking at it like it is amplitude. Instead, you have to put the k value from the equation into a formula, and the formula is sitting right up there in a bracket. You may have used a slightly different formula in grade 11. In grade 11, you may have used 360 degrees over k, or divided by k. That is okay, but because it's grade 11, it's in degrees, and I'll be giving you information in radians this year. So this is something you're going to have to pull off for every single question. So we've got 4 questions here. I've made them movable. So I'm going to move C and D out of the way. Just a little bit. And I'm going to make you do a little bit extra, although I'm doing it as well. We're going to talk about amplitude and period with each of these, including the 2 down below. So we're covering both items, both characteristics that we've looked at today. So for the first question, and this is just calculating, so it's not doing anything with it until I tell you otherwise. So the number right after the equal sign before the curve's name, so in this case y equals sine x, that is an amplitude of 1. There's no flip, it's basic. The period requires you to use this formula up here, so we have to use 2 pi over k, and we have to go searching for our k. Whoa. And our k is that thing. So we have to pull off 2 pi over 2, and then we have to clean it up if we can. So 2 pi over 2 means the 2's will cancel out, or 2 divided by 2 is 1, so I'm going to write 1 pi. And that's all I want you to do for right now. Let's look at the second question. Amplitude is the number right after the equal sign. Doesn't matter if this says sine, cos, doesn't matter one bit. Doesn't matter if this is an x or a theta. Period is 2 pi over k, so I'm going to keep writing down this formula. even though you don't need to. It is a note. So that's 2 pi over 3. And 2 pi over 3 cannot be made to look any nicer, so we're done that. Next question. Still working on both characteristics, so I'm going to do amplitude. And we'll talk about the period or wavelength. So in this question, even though it's not one of the ones I'm going to eventually graph with you, in this question, the amplitude is 3. You always state a positive amplitude. When I ask you how high something is, you always state a positive. Now, if you're graphing, you may want to mention to yourself, oh, this one's going to be flipped. If you're not graphing, you can mention it or not. Either way, you don't have to tell me that. It just has to happen when I go ask you to graph or sketch. Period. This one's a little bit tougher. I'm going to say that because I'm going to guess that the average human being isn't a big fan of fractions. So in this question, and I'm going to run out of space, so I'll put it here, we have 2 pi over a half, because this is the k value. So to show a little bit of work, that's 2 pi divided by a half. So if we write it a little bit old school, and 2 pi divided by a half, think about grade school for a second. That means you have to times by the upside down. So that's 4 pi over 1. So the period, after all that math, ends up as 4 pi. Which actually means that regardless of how tall it is, it means that you're going to start your curve, whether it's sine or cos here, and you're going to end it, for the purposes of this, like off the page, because it'll take you 4 pi. So you've stretched this. Last question for characteristics before we start to graph, or I guess sketch is a better word for it. I'm not sure why that happened. Bear with me. Okay, so this one's a little preview of what's to come. First thing, amplitude is a 1. It's got a negative. You ignore it for the statement of amplitude, but maybe remind yourself that we're going to have to get this flipped. I'm not going to write the 2 pi over k. It's got to happen anyhow, and we do 2 pi over the k value, which is 2. So this time it's the square bracket round bracket deal that I told you might happen or might not. And 2 pi over 2, actually we can make that look prettier. The 2's cancel out and you end up with pi. And then finally, if I go back to the very, very first slide, and I look at what I put in the bracket, that's a C value, that's a phase shift, that's a horizontal, so side to side translation, so a movement. So when I ask you what's happening for this, I'm going to say that there's a phase shift, which in future lessons I will abbreviate to PS. There is a phase shift of pi over 6. So you can see that. But if you remember from grade 11, with all the other graphs that you were looking at, or maybe even the trig graphs, when you have a sideways movement, you go in the opposite direction of this sign. So if you think about the x-axis, which is horizontal, negatives are to the left. That means this is going to go backwards, so we're going to go pi over 6 to the right. So here's where I take a little break and I do a little cutting and pasting so I don't have to keep flipping back. So I'm going to put A and B on one grid, so I'm going to cut and paste it. I may have to do a little scribbling, so I'm going to create a little scribble land for them, and then we'll look at D, and I'll do that on the other grid. But I need to set up some information and do some cutting and pasting, and I'm sure you don't want to watch me struggle with that. So give me a moment. Okay, I'm almost cut and pasted. I haven't done question D, but I've done A and B, and I assume I will need a little handbrake for this because drawing these curves is actually quite stressful on my right wrist. So here's the criteria from A. Notice how I've pre-labeled X, and I also cloned my work down here. I know I've mentioned earlier that you could have some theta questions. It is true, you could have some theta questions, but chances are very good that your tests will have X's, mostly because I don't have a theta button on my keyboard, but I have an X button on my keyboard, so I don't have to dig into any crazy symbols. So just out of pure laziness for myself. So I've pre-labeled that. I've pre-labeled my 6 boxes so you didn't have to actually watch me count them. I am going to make you watch me count them on D because I do want to share with you some information. So, I didn't label my y-axis because I need to make sure that I'm labeling appropriately for my amplitude. I'm not moving this up or down today, so I just need to go up and down to whatever this value is. So I'm going to be dangerous and make this one and this -1. Now it's not dangerous today, it's dangerous tomorrow, so just don't worry about it yet. So here's the scribble part that I do. So I'm going to rope off a little scribble land in a second. I'm going to call it scribble land, but SL for scribble land. We need to talk about the fact that our period isn't the same. Our period is pi this time. We made our calculation and came up with that. And for my system, and this is why we're going to talk about a little bit extra in D, but for my system, I've decided that the period is 6 boxes all the way along. If you want to change it, you are allowed to change it, but you must be consistent all the way along, either in the positive and the negative areas of the x-axis. Now another thing we have to talk about is the spacing between the dots. So if you take whatever calculation your period gives you and you divide it by 4, that will give you your spacing. And this is the worst that it can be, is that it'll be a halvesy. So I'll show you why in a second after I pull this off. That's my scribble land. This is a sine curve. So because it's a sine curve, I start at the center. There's no flip, so I haven't super tricked you in any way. I know I'm going up to the 1, but I'm going up to the 1.5 boxes later. So 1.5 boxes, I'm at the 1. Then 1.5 boxes, I'm down through the center. So here's a half and there's a full one, so that's 1.5, and I'm back down through the center. And then 1.5 boxes, and I'm at the bottom, which in this case is a -1. And then 1.5 boxes, I'm back at the top. And I can continue that, and I'm actually going to continue that for a little bit in a minute. What I do want you to know is that you've got a complete sine curve sitting here, and it's sitting in pi amount of space, which is exactly what you said. Now, why 4? That might be one of your questions, and it's a good question. It's 4 because there's 4 quadrants. So here's the movement for quadrant 1, here's the movement for quadrant 2, here's the movement for quadrant 3, there's the movement for quadrant 4. It's also got 4 attachments between the dots. So that's why it's always 4. That never changes. So your spacing is always whatever that number is divided by 4. Never changes. Don't let anybody tell you any different. So, because I've already got the red curve there, I'm going to keep going just for fun and to see if I can count to 1.5 repeatedly. How's the silence for you? Can you hear my clock ticking? There we go. So a couple of things I want to tell you. Number one, this is 1, 2, 3 cycles. I could ask you for 1 cycle, I could ask you for 10 cycles, I could ask you for 2. I've decided to draw 3 of them. Another thing I want to tell you is that we went from negative pi, dead even with negative pi, with our x's, all the way up dead even to 2 pi. So I can ask you in 2 ways how to graph these. And the last thing is, if I shade in the curve from 0 to 2 pi, and I'll get rid of this in a second, but I want to shade it in temporarily. If I shade that in, how many cycles is that? 1 complete cycle, second complete cycle. So we have 2 complete cycles, and it is not a coincidence that that's a 2. So the k value actually indicates how many cycles you should expect in 2 pi amount of space. And that's because we're taking 2 pi and dividing it by the k value. So that makes some sense if you want it to. So let me get rid of my scribbles. What do I need? I need that thing. And let's go on to the second last question. So I've left myself a little bit of space to do some work. Why can't I find things? And I've got my grid, except for how I'm going to label the y-axis. That is a decision that I leave for a little bit later, because I choose to not think about my x-axis, because the very worst kind of question you'll see in a book or on a test or a quiz is a 0.5 spacing. I may ask you criteria that gets you to do worse than 0.5 spacing, but I would never actually get you to sketch it. And this is sketching, not graphing, because all this space in here, that's guessing. The only graphing part of this are to find those exact dots. So my amplitude is 2, and again I have no flip, so I'm going to be undangerous here. 1 box is 1. And this is a sine curve, so I'm going to put down my first dot so I don't have to think about it, and then I'm going to go make myself a little scribble land. Because this time my period turned out to be 2 pi over 3. So pi was 1, 2, 3, 4, 5, 6 boxes. So I'm going to literally turn my pi into a 6 and pull off some math. So 2 times 6 is 12. 12 divided by 3 is 4. So my period is 4 boxes. So what that means is that my curve is going to get smushed into 4 boxes worth of space. Smushed is not a mathematical term. Now, I like to just count, so I'm going to take my spacing, take this number just like the last time, and divide it by 4, because I have 4 quadrants or 4 movements, and I end up with a really nice 1 box count. So if I can count to 1, I should be pretty successful. So count to 1, go up to the 2 because the amplitude is 2. Count to 1, count to 1, 1, 1, 1, 1. Just for fun. There, I'm done. Connect the dots with a curve. Ugh. Okay, that I'm not proud of. So some of the things I'll be looking for: make sure you don't have 2 up bumps or 2 down bumps in a row. It's alternating. Another thing is, and I've mentioned this earlier today, all your up bumps should be going through the same spot. All your down bumps should be at the same level as well. Now, just for fun, I'm going to dig out the highlighter. This highlighter, let's use blue. Start at 0, color my way all the way to 2 pi. How many cycles do we have? 1 complete cycle, 2 complete cycles, 3 complete cycles. Oh my goodness. Not a coincidence. All right, so if you'll bear with me, please, I am going to back this all up, and I'm going to pause and set up for question D, our final one for today. So I promised you that you were going to watch me count this time, and it's because I am suggesting to you to go 1, 2, 3, 4, 5, 6, lay down a pi. 1, 2, 3, 4, 5, 6, lay down a 2 pi. Let's say you do 1, 2, 3, 4, 5, because 5 is your favorite number. That means when you go to do Scribbleland, you're going to take the period, which is pi, and you're going to say that it's 5, and then you're going to go find the spacing. And the spacing is going to be 5 divided by 4 every time, and you're going to get 1.25, which is not so nice. Maybe you want it to be 4. So your period is still pi, which is 4. And then you go, okay, this is going to work out really nicely for spacing, which is 4 divided by 4 every time, and that's 1. And that works out really nice because you can count to 1. The thing is, as soon as I add in a phase shift, that's asking you to move this right or left. And pi is still whatever you designate it to be. So in this case, you've decided that it's 4. Pi is 4. You made it be that. So you're going to take 4 divided by 6 and be asked to move 2/3 of a box to the right. Good luck with that. If it was 5, 5/6 to the right. Good luck with that. What I am attempting to do by getting you to use 6 boxes as pi is I'm attempting to get you to use some really nice numbers over and over and over again. So that's why, in case you're wondering what the heck my rationale is, I like 6 because it almost always works out perfectly. Again, the 0.5s are kind of unavoidable, but pretty easy to deal with. Way better than 5/6. 1, 2, 3, 4, 5, 6 is pi. That's my preference. Actually, my preference is 12, but I don't have enough graph paper for that. 1, 2, 3, 4, 5, 6, 2 pi. 1, 2, 3, 4, 5, 6. Are you sick of me counting yet? 1, 2, 3, 4, 5, 6. Now I get to stop. And I can't steal my work because it was on another page. What about my y-axis? You have to label that. And this is a 1. I don't care because I'm not moving this up or down, so I'm going to be dangerous. I'm going to live dangerously here. So, this is a cos curve. Ooh. And my cos curve, I'm going to do this in green, and I'll tell you why in a second. My cos curve starts at whatever value this is. So my cos curve is going to start at 1. Then I'm going to go and make myself a Scribbleland because I need to know how far to count to get to my next dot. So the period is pi. I've designated pi as 6 boxes. My spacing is 6 divided by 4. So that means that I'm going to count 1.5 boxes to the right. So my challenge is figuring out my left and my right. So 1.5 boxes to the right, plant your next dot. 1.5 boxes to the right. Ooh, did you catch that? So this time I'm not landing on 2 pi. I like to come back to an axis just because it looks sort of nicer. So I'm going to go there. Now, if you want to, that was a bad idea. If you want to, you can connect these dots. But the thing is, this isn't our final curve. And the reason it isn't our final curve is because we haven't taken a look at the phase shift yet. So we haven't taken this picture and we haven't moved it pi over 6 to the right. So I have to worry about that before I do anything. So if I haven't mentioned it before, right and left is a problem. So Scribbleland again, I draw a little line to say new thought, phase shift, pi over 6 to the right. I've designated pi as 6 boxes, so I do 6 divided by 6. I literally plug it in, and I come up with 1 box right. So now I'm going to dig out a new color. I'm going to go back to red, make this all Christmas colored, and I have to figure out my left from my right. I didn't really have to think about it for spacing. And then I have to go 1 to the right for everything. So this one's going to move here. This one is a halvesy, will stay a halvesy. Move here, and so on. And my eyes are getting tired. And we connect. Now, if you have done what I've done here, and you've put 2 curves on one axis, set of axes, your job is going to be that you have to label it. So you have to come up with some inventive way of labeling it, whether it's to extend and write y equals negative cos square bracket 2x minus pi over 6 bracket bracket. Now, if you want to, and I will put this back in a second, you can erase this other curve. And the reason I say you can do that is because you don't need the curve to move the points. And if you don't want the curve, you're not going to need to label because you've only got 1 on there instead of 2. So you've got some options, and it depends on how comfortable you are graphing and how well you can read your own, I'm going to say writing with air quotes, because it's not writing, it's drawing. So that's a little preview of tomorrow, or the next lesson. The next lesson includes amplitude, which we've covered here, period, which we've covered here, phase shift, like we haven't seen it, even though we just saw it there for a second, and I'll be dealing with vertical displacement, which is an up and down movement, and why this system is super dangerous. Okay, so I believe there is something I forgot to mention, but I'll catch it in the next one, I'm sure. I'd be happy if you could rope me off your Scribbleland. Oh, I remember what it is. This 6-box deal, this is our special language of drawing curves that are sine and cosine curves. So this is our special sinusoidal language. So if somebody asks you what the period is, you never tell them 6 boxes. That's why all this stuff is in Scribbleland. You can put whatever you want here, except you can't insult me. If you're talking about going on in math, you can't put that, and you can't put this, and you can't put that in this space. You are allowed to do it in Scribbleland. This is where you scribble These are the specific characteristics that every math teacher will accept. This stuff, the stuff that's sitting in Scribbleland, just giving you a hand trying to graph this thing or sketch. So if somebody asks you for the period of a curve, do not ever tell them 6 boxes. Do not ever tell them 4 boxes. They're not going to know what you're talking about. They will accept 2 pi over 3. They will accept pi. Same deal with phase shift. Do not tell them 1 box to the right. You have to tell them pi over 6 to the right. So that was the important thing that I almost forgot. Now, another thing I almost forgot was this int math thing. There is more than that, so don't pay attention to that. It's different. The int math thing, and I'm going to use my niece as an example for int math. If you, and you could stop here, remember you can stop anywhere, you could believe this or not, but this is a cool little thing that has no mathematical value whatsoever. And this is sort of like horoscopes, only a little bit more sciencey, but not a heck of a lot. And that is, apparently, you have 3 cycles in your life. You have an emotional cycle, a physical cycle, and an intellectual cycle, and they all start on the day that you were born, which is day 0. Your physical cycle is this green one. Your emotional cycle is the red one. Your intellectual cycle is the blue one. And you can see that they're all sine curves because they all start at 0 and they all have different wavelengths. So if I go down below, instead of counting boxes, your physical, whoa, baby, your physical cycle is 23 days long and then repeats itself. Your emotional cycle is 28 days long, then repeats itself. Your intellectual cycle is 33 days long and then repeats itself. So you can believe this or not. It tells you whether you're going to have good days or not so good days. So I'm going to use my niece as an example. My niece was born on, she's 5, the 19th of May, 5 years ago. So 2015. And today, you can tell here, 9:40, it's almost the 17th, but today is September 16th of 2020. I care about what kind of day she's having today. Sort of. So I'm going to set her back to her birthday, and everybody starts their life positively and then moves negatively. But I'm going to show you today. So there it is. It's blue highlighted. Green tells you that you're having good days. Red tells you you're having not so good days. So she's been alive for approximately 1,947 days, and today she's pretty normal-ish, as in not having a good day or a bad day with blue, which is intellectual. She is not having a good day or a bad day emotionally. Physically, which is the green one, she's on a downswing. So maybe she's not going to feel well, and I'm not saying she's sick, but maybe she's going to feel, grumpy because she's a 5-year-old in the next few days. Maybe I should warn my brother and his wife. I want to find out what she feels like, or what she might feel like on, let's say, October 1st. So I can predict the future, or I can check the past. And I'm going to show this. So here's October 1st, which I might have been able to see on that last one. On that day, she will be born, or she'll be alive for 1,960 some days. But on October 1st, her green cycle is high, so she's physically good on October 1st. She is coming into being emotionally okay, so maybe I should visit her, because a 5-year-old is testing of my patience. And intellectually, she's still in the positives, but she's going to be heading for a downswing. So here's Thanksgiving Monday. Emotionally, I don't know why it's blipping. Emotionally, she's okay on Thanksgiving Monday, but physically and intellectually, maybe I don't want to spend my weekend with my 5-year-old niece. Just kidding. Anyhow, you can check this and believe it or not believe it. Another thing you can do is show the composite curve, meaning you can show the overall look of how you are looking that day. So this is for her. Where is it? It's the purple one. So it's not going to look exactly like a sine or cos curve. It's going to be a curve, but it's a combination of 3 of them, so it's a bit wonky. And that's how they get the overall greens and reds. So that might interest you. Maybe it might have no interest to you, and you should have shut me off well before this. So I always like to show that because I think it's hilarious what people will believe. You can believe that as much or as little as your horoscope. Anyways, have a good night. I think I'm done, and I'll do combo questions tomorrow night. Or maybe I'll get a burst of energy. No, I'm going to watch Law & Order SVU. Good night.